All right. So give you in, then for each of those I give you 2 lines. The first is the key, and then second is the text to run the cipher on. Yeah, I guess we can do that in Python, or at least to start. I feel like this is one we can probably do fairly quickly, so I can go through it in C++ or Java too. So all right, and then read. So right now I'm just reading in the number of test cases, and then I'm just gonna do that for that many times. So see, they had 2. So for it'll loop twice, and each time it'll read in the key, and then it'll read in the ciphertext. So that's just getting input. So we need to create the substitution string, yeah. So the thing is how to do that.
You don't have to do like one column.
Yeah, I was gonna say, I don't think you would have to.
Yeah. Well,
I think you can just use slicing and do it by step, according to the length of your key. So like, you've got secret, so you've got 6 letters. Well, yeah, you have to drop the repeating ones. So you've got 5 letters, right? So then you take your alphabet, A, B, C, D, E, so on, and then you grab them by fifths, yeah, because it's the length of your thing there. And then
it puts it in alphabetical order, the keyword we're using.
So you have to,
and then it keeps,
right,
yeah,
so we'll
places them
then
basically.
sort that, and that would be C, E, R, S, T, yeah.
And then it's
Okay, so it wouldn't be that. It would
what
be.
is that?
it is, but it's grabbing it by
It is, but it's offset, you know. So it's like you start at C, right? So you would find C, do that, and then grab every fifth. So
Well, you would start by taking C, E, R, S, T out of the alphabet.
look at their substitution window. I don't think you remove any from the alphabet, do you?
Yeah.
You're just taking it and you're taking them in groups, and then you're just mixing around the letters. You're not actually changing anything. You're just changing the order they're in.
Yeah.
So you go A, B,
I mean, they still got all their letters though in the
But not
substitution window.
where it says secret, it's an A, B, D, like there's no C in that.
Ah, okay.
So the
How did they end up getting all the letters though in the substitution one then?
because they find a column that has C and they just dump all the column into A, B, C, D, E, and then they find the next one, and then it just ends up being 26.
They included S, U, C, or T in there. But it's
Oh, that's your starting letters.
first of
Yeah,
each
that's your
row.
starting letters. Okay.
They're the first of each row.
Okay. So yeah, all right. Well,
So your keyword is going to be the first of each. Once it's out.
yeah.
Is this really even encryption?
No.
This is ciphertext.
Yeah, it's just a cipher thing. So you go through, remove all of those letters. It's all of them that I've got up here. And then you go by bits. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So on. Right.
And you have to go through and see where C is in that index. And then grab all that column of that. It's probably easier just to do it in a multi-dimensional way
Probably, yeah.
rather than having to split. You can also
What if you
optimize
got-
it later.
So we're wanting to separate them into groups of 5 and then reorder those groups of 5 based on the alphabetized order of the keyword.
2, 3, 4,
And that's
5.
sequence.
2, 3, 4, 5.
So for C
Yeah.
first. So you'd have to automate that.
So
You
can
alphabetize it.
You can
and
keep
like
you can keep the normal alphabet, and then for each of these you'll get the index of it. Yeah. And I was gonna say just add 1, but then what if B were also in that? Wouldn't work. Yeah, probably best just do a multi-dimensional. Yeah. So.
So you can sort your first index, your first row, and then figure out what index the leading
Right. Okay, so we need to first sort the key, or get the unique letters and then sort it. So key equals.
You sort it after you match up all the letters. So
Okay, so just. Alright, think that'll work? Yeah, that worked. Just assume it works. Alright, so. After that is create the, yeah, matrix, man. Yeah. Well, there's a thing in Python though. Once again, my Python thing. There's a thing. It's like, I think it's, yeah. There's a string library and it's got the alphabet in it. So I don't even have to type this out. But by the time I actually look up how to do this, I could have just typed the whole alphabet. So, you know. Yeah. Well, I would need uppercase, but yeah. Alright, so we'll do letter or what in ASCII uppercase. Or no. Yeah, this is it should just do this. Oh man. So we need to remove all the letters and then make it into that,
Well, I
right?
wouldn't remove the letters.
No?
I would just go through and start at like A, B, and say, like, you have an index of your current row. So this is like super Java-y, so it's probably easier with Python with sets and all that. But you just did add it to the column if it doesn't exist in the key. Just so you're not having to do like string manipulations with like replacing characters in a string with another string.
Yeah, but I mean, if you just copy the uppercase letters string there, then you can just split it by the length of the key. And each of those is your rows. I mean, if you do, so see, And I think if you have a string like oh, I have to convert to a list. I was gonna say I think you can just put in like an arbitrary amount of arguments to that, and it'll remove all of them. No, okay, I lied. So you just do that, and then for letter and key. Yeah. And then, so new letters is now the removed one, and then
To prepend the key to the letters.
you're talking about to make like the whole substitution thing. I was just gonna make the matrix first, but yeah, you could shortcut it though, like you're talking about if you want. You would just
Because right now you have the ABDFGHJ.
yeah, I have that, but just all on one stream.
I guess you couldn't go straight to the substitution.
You could probably be easier to not mess up though to make the matrix. So if we do rows, that's like think of rows. New letters. The slicing is. We always try to do this, or I always try to do this, like trying to do the shortest amount of code as possible. And here.
Is there a function that will yield the substrings?
Well, you can do 4s in this is what I was trying to do. I don't know why I was just blanking for a second. You can do letters and then yeah. So what that'll do is slicing it. It's taking the string and the way the syntax is, like I've went through that before, but the left of the first colon is your starting index, then between the two colons is your ending index, and the last bit is the step. So it's like if the step is 5 right here, it'll grab the slice of 1, 2, 3, 4, 5, just like we want it to, and then we'll do another one. So for that for loop, S will be A, B, D, F, G, and then for the next iteration will be H, I, J, K, L, and so on. So, and then you can just do that. Or you don't even have to convert to a list, you can just do that. So now the matrix is a list of all those strings, just like we want it to be. So after you have the matrix,
You need to add the key to the matrix as well.
yeah. I'm going to print out the matrix and run it real quick, just to make sure we did it right. Oh, I didn't do slicing. I was only grabbing single letters. See, it's like the first letter of each one, or their first input. It's go off the second input since that's using the key secret. So AH and AH, yeah. So it's right. I just gotta fix that. See, I don't know if you can do that. Grab those. Oh, this is weird. I wonder if you can split a string by like just the ranges. So I think I still have this. No. so. Maybe you can. Let's just look it up. Yeah. Of course, I just wrote their own function. It's like we could have done that, but string.slicing. Oh no, it's, I know about string slicing. That's what I was trying to do. And then there's this solution with iter tools. It's like, that's too much. I'm surprised you can't do that in Python, actually. Anyway, let's do just number it, do an enumerate thing, so it'll keep a index for each letter I'm on. Like I will be 0 through whatever 26, then, or actually less than that. And you could say if my length key 0 to 0, then or not equal to 0. Actually, I can do that. Then we'll add the row to it. Otherwise, we'll add add the letter to the row. Does that make sense? Yeah, sure. Nope. It made sense in my head. I was looping through the new letters and the string we have, creating an empty row. Oh, well that's my problem. For each letter, I'm setting it to empty. Right. Try that. B, D, F, G. It's almost right. Yeah. Sure. No. Oh man. Let's see.
You need to put the length plus 1 in parentheses.
You mean
I think it
the whole thing?
It evaluates that for
Oh yeah. You're right. That was dumb. Yeah. So yeah, we don't have it's taking A out, so it'll be B, D, F, G, H. To see now that's wrong. Is it? No. We have because I've removed the new letters. Oh well, yeah. So that's right. B, D, F, G, H. I took an I out too. You can print new letters too.
So you're not adding. When you say you're at the end of your key length, you're just appending the row. You're not adding a character to the row in that first if statement.
Oh, so I need to do that.
I don't know what that means now.
It's exactly how we want it to be, right?
Now you gotta bring your plus 1.
Huh? Oh, remove the. Okay, sure. like that though. Should be. Yeah, it doesn't make any sense. Because it's cutting off when it's 0 and all that.
You can set your row equal to the new letters, or not new letters, the key. Because that's what the first row should be. So row is the key. I don't know, make sure that's a problem.
Yeah, I don't think it will, but it'll give us that first thing correctly.
Is it sort?
Should be.
Or does set sort?
No, it doesn't. R, E. So,
It should be Z first, though, right?
well, I mean, it changes it, but it's kind of arbitrary. So,
But it needs to be in order. That key needs to be a specific ordering.
dang it. Let's see.
I think it's just reversed.
So you can do A, R, E, B. I think so, yeah. Here's their,
Pass it.
we can do no, yeah, you can't do that. I mean, you can always, never seen Python be this much trouble. Let's do this and wait, we'll just reverse the key. Will that work? No?
Set doesn't, it doesn't
Yeah.
print out reverse.
Are you sure?
Yeah. Like,
It looks like it is.
but
So click the
like the reverse thing
A.
of that?
R, E. Then the next unique one would be. Oh no, it'd be S. Never mind. Yeah. Well, we can. Here, let me just not use that. Then we'll say. This is a bad thing to do in Python, but it gets the job done. Let's say if oh no here. Geez, nice. Here.
No, you just need, you need a new key, and then for C in key, if C is in key, or not in key, just add it. You only need one variable. And not under new key.
Yeah. And since I don't feel like changing the word key later in the code, it's beautiful programming, right? Secret still off though with that indexing. Yeah, we got the order right, but the indexing problem is still there.
Because it's just trying to zero. Zero under zero is.
Yeah, it doesn't make sense. Like, it doesn't make sense why it's cutting it off there.
Print the I and then the remainder. Probably Python's fault.
Ah. Let's see, 0, 0. Wait, what? Yeah. Yeah, it doesn't make sense. Because
Wait, what if you're I think you're overriding it's 0 is the matrix of n to row plus c. So it's gonna, the first time through, it's gonna append row plus a, and then fix itself. And then it's gonna,
okay, so I need to do.
no, you see the fix there.
I can do that. Not row. I can do that first off. That just puts the first one in there. So I'm not gonna fix it though. Yeah. Here's that. Man, I've never.
Doing the
Jeez.
0.
It's the first time. It's like so it's got A, right?
Because when it starts at 0, and so it goes.
Yeah.
It's 0, like so A is 0 essentially. It does matrix dot append row plus c. Row is empty plus c is A, so it appends just A.
Right.
And then it goes row whatever, and then it goes 1, and it does the else 2.
Yeah, but it shouldn't run this on the with A, should it?
Well, it's a 0th index, and that evaluates as a 0.
So I need to say I plus 1 then?
You could just make a special if statement for the first case.
What if? What if? I say
Why don't you just
do that and then now into it. Oh, it's so bad.
You need to do if I remainder length is equal to length p minus 1.
A, B, D, F, G.
Still missing
There you go. Oh, I can just do. Oops. Outside of for loop. That work? Yeah.
unless it's a column or something. I don't know.
I think that'll work. Alright, so we built the matrix, yay. Now we just have to query our users, red or blue. So after you build the matrix, wow, it took us that long to do that. Try to tell you I'm not a good programmer. So you built the matrix. Now, now we sort the keyword, correct? Yeah, sort the keyword, and then for each, you just do a index counter of that. So we,
The 2, 1
so just find the
index of that in the
yeah,
original.
you find the index of that in the original one, and then take the column for it from that. Okay.
Do that right. But I have to do like key dot index and then the character that you're currently at.
Hold on, say that again. Key dot index.
Like you can do a
So if you do,
for
yeah.
C and is there sorted somewhere? You can do
Yeah.
like for C and sorted key.
Yeah.
And then colon I equals the index of the original
RC and sort of, yeah. Yeah. And then now we just got to write a little bit to get the column. Which, what about the very last one with
Using
with
the
the,
string, you need to append the string for like,
yeah, but we're gonna have to watch out for the very last one in the case it's like, oh, column 3, but there's nothing on that one. I mean, we don't want Python to yell at us. This is the longest Python I think we've ever written in here. A lot of, yeah, messy. Let's go to the discussion. There's like 3 lines. Okay, so C, B.
you need a string outside your for loop. That's gonna be your final transposition sequence.
Yeah. Okay. Please don't tell me I'm gonna have a for loop inside a for loop inside a for loop inside a for loop. Well, we're already in one for loop. This is another for loop.
So you got 3 for loops.
Not 4?
Minus 3.
I don't know. We can push it. I'm just kidding. I don't want to. So.
Does an inline for loop count as a for loop inside of a for loop? Inside of a for loop?
It's too much, man. Too much. So. Think you do less than equal to? I don't know. Sure. Huh? Sure. Sure. Yeah. Sure. Maybe? No. Outer range. Alright, let's change that to that. Huh? No? No? Oh, we didn't do spaces. Yeah, you do. Like their expected output has space between each
Well, this is
section.
This is just the substitution thing for right now.
Oh, we haven't even.
We haven't even done anything with the
Ah.
input yet, ciphertext. But is that substitution correct? It's a
CDJOWEBIN. Yeah. Ends in QY. Yeah. So now that we have the substitution, we just do the rest. Yeah. Another 4. At least we know the data isn't that big because it's like it's only 26 letters in the alphabet. And, huh? Yeah. Hey, you know what? You know what you can do? If we've got our substring or substitution string, and say that equals something like that. I don't know. Then you've got your ciphertext, which is, let me use the same letters. Yeah, so, I don't know, something like that. You can. Never mind. You can't. I was gonna say you could use a zip function, but they have to be the same length in Python. There's like a izip thing in itertools, but that's too much work. So it's the one that doesn't care about the length, but it's still kind of trippy if the lengths are off. So yeah, we can just do what you're saying. the index of it in the regular alphabet?
You want to find out where it is in the alphabet, and then do
Okay.
that to your substitution.
There's still gonna be the space thing, but yeah. What? Substring. Where did I say substring?
Check for your space first. I think it's trying to get the index of the space and can't find the substring of the space.
What do you mean?
I don't know, it's like substring. I think it's because of the space though. The Turner statement.
So I can just say no, it's not right. Well, I mean, I don't know. Why are you? If you got your substitution string up here, right? Substitution. I mean, all you're doing is like So you got C, D, J, O, W, blah blah blah, and then if you got A, C, B, then it should be. It's like A is the first. Okay, never mind. I see what you're doing. Never mind. That was them. Same. Go to plus equals substring ASCII.
What's the output?
Well, it's
What's the output get?
huh? Oh.
Totally out.
Yeah. Just a little bit.
Sounds perfect.
It's off by 2, isn't it? No, never mind. I was looking at the end and it looked off by 2, but
Because like that first one is a CR and ES. E is the same.
yeah.
W.
Trying to see if you got. Index is 0. Substring 0. I don't know why that won't work if our substring is correct. 4C in cipher text.
Can you print the substring in there?
Yeah.
Because that is what we're doing, right? We're trying to get.
Yeah. It's substituting. So it's substituting J for V.
We want to see.
Yeah.
The substring starts with C.
And V is way over here. See, A, B, C, D, E, F, G, H, I, J. That is the J. That's the position of J in the alphabet.
Yeah.
Yeah. So
But they're
why are they?
position of
How are they getting C then? I think we misunderstood the problem or something. Yeah, how the output is. So transpositions. That's crazy. Alright, so this is the same thing, and they gave us J, and they wanted, I mean, it just doesn't make sense. Like, we're doing the standard transposition or substitution cipher. Hold on. Those are different. Transposition cipher and that are different, but it's like what they're calling transposition cipher, I don't think is a transposition cipher though. Like, it also uses a matrix, but still, it's like yeah, because with the regular transposition cipher, it uses the length like that, yeah, but I don't know. That's I'm just gonna look at the next letter. So then they give H and are expecting R. H.
Well, right. No, that makes sense. Cause
Does it?
yeah. Cause, we don't wanna find, if you look at the substitution and you find the index of H in the substitution, the original is R. So we need
Oh,
to
we
find
have
the
it
index.
backwards.
Yeah.
Okay. That's weird. You normally don't do it that way with substitution. Okay, so we need to go phi decoded plus equals.
The ASCII uppercase from the substitution.
Gosh, Sam, come on.
Yeah, man.
Get with it, man.
My bad.
Oh, yeah, it also might help if I take out that print statement. It might, but you
Nah, you
just
don't.
guess. Ta-da! Jeez, it took us this long to do an easy problem in Python.
Just remember,
Feel so prepared
this
for the
one right here
contest, man.
had a 0.18% pass
We're-
rate.
We're gonna do so well at all these contests.
Is that a 0.18%?
Adam will at least.
That's
Yeah, as well says
even right.
two cases. It was the cases they gave us. Oh my gosh. Yeah.
Man, it's almost like cryptology is just mixing a bunch of letters together.
Wouldn't it be funny if this link just went back to the problem? What? I don't feel like reading all that. Oh, like here's the Python. Yeah, that's getting the unique letters. I don't know why people in Python do this. You can just say temp equals res. Like the shallow copying isn't an issue either. So
Good job, guys.
wow,
You did it.
does that actually work?
Is that the full solution?
Yeah, I don't know. I'm gonna test this.
He's not really printing things like that.
Somebody commented below and said, "Oh, thanks, whatever." I swear if that works.
He doesn't print anything.
Ha.
No,
Yeah, that's not the full solution.
it's just most of it.
Cool. It's like you see like if you ever like find like a cryptography video or something on YouTube and stuff, like people will leave comments like, "Oh, here's this encrypted message. I'll give you $100 to whoever can figure it out." And I'm like, no one's gonna spend the time to figure that out. And the people that do, I'm like, oh man. So anyway, I don't guess we will be solving it in another language. Can probably narrow this down, but it's still gonna be a lot.
I think you could 4-line it. 3 lines mean 4 loops, and 1 is the out statement.
I don't know if this will work or not, because Python is weird about this kind of stuff. Like if you ever look at the Fibonacci solution in Python, it's weird because of the timing of it or something. Like, I don't know. It's like the order that it runs things. It's not going to work, I bet. Yeah. You should do what? Yeah. Yeah. As I say, I still don't think it would work. Yeah, because see, it's not, doesn't know what new key is right there. No, so. Yeah, but no, it's reused ones. It's worth a shot. We'll just let Sam figure it out later. Cherokee, you can have the Perl solution. Yeah. Give Hayden the Lua. You can handle Lua. Adam gets Haskell. I'll take Java. I mean, I'm giving you guys the easy work. Yeah. Nah. I don't even feel like improving that. I think we'll call it there. There was an AI one I was looking at. It's like you write like a cleaning bot. I get that you're excited that we're done, Cherokee. But no, like, yeah, there's a cleaning bot or something on here that I was looking at. Yeah, bot clean. It's like, basically they just give you this. It's a 5x5 matrix every time. B is your bot and D is the dirty tiles. So basically you just like use Euclidean distances and find the closest dirty spot, and then you output like the direction to go each time, and then whenever you're at the spot you output clean. So I started working on a solution, but I've got something wrong. But it's cool, like when you run it, it actually shows the board here though. So mine doesn't work right now, but yeah. This is similar to Coding Game. If y'all have never seen that, like if you actually go onto a problem, it's pretty cool. Like you get to see your bot move around and stuff. So
on top of that, it just lets you mess around. So like even if you don't solve the problem, it'll show like the effect that your program has on.
yeah.
So even if you're not.
It's like just runs into a wall and tries to run over or something because you're array indexing or something. Yeah.
It's great.
It'd be funny if they did that and they just like fall off the edge of the earth. It's like, that's what you get for using the wrong indexing.
I kept messing up mountain one.
I've done this. The problem that it just showed the little motorcycle, that one was pretty fun. It's like you have to write code to figure out the amount of like when to slow down and accelerate on the motorcycle to make a jump perfectly or something, like on a ramp.
That one.
It's
Have
pretty
you seen
cool.
the answers for that one right there?
This one? Mm.
Yeah, that one that's like a turret that's defending itself. That thing, there's like people who have like machine learning for it. It's crazy.
I wouldn't go that far.
They have like the most efficient way to do it. It's insane.
Oh, not contest training. If you go into training, there's a lot
It's
of
in there
those.
somewhere.
Yeah, there's the Chuck Norris one. That was a.
But yeah, it's just a bunch
Mm.
of games you get to play. Probably one of my favorite places to go to practice.
Yeah. Even some of their easy problems though are fairly difficult. This one was pretty simple.
Oh yeah, that one.
So we're
It
yeah.
took me a few minutes. I'm not gonna lie. It took me like.
Well, it usually takes you a few minutes just because you have to like thoroughly read the stuff. So
All you do is just get him to go to the light. Yeah.
I don't know if
This
it.
one took me a
Yeah, it
while.
kept my solution. Yeah.
I had it where like you can only move one in any direction, including diagonally. But
Yeah.
you made him move.
So it's
based
like
on
yeah.
that.
So this is like
Yeah. Like that.
straight line. And it's like this is his target. So all this is basically the same thing as the bot thing I just showed. And there's like yeah, up. Yeah. Easy angle,
My
optimal
diagonal
angle.
would go past it diagonally by accident. Like I would have it move diagonally, and then it would like meet the X requirement, and then it would continue to keep floating to the right.
Yeah.
I had that problem for the
So.
longest time. I couldn't figure out what it was.
Pretty cool. Just gotta use Dijkstra's algorithm. Man, imagine writing Dijkstra's algorithm in this tiny window. I mean, you can make it bigger, but still.
They're not optical, so you choose putting distance.
Yeah. No, like the bot cleaning one, like I looked at the discussion on that and people were arguing over which thing was better, Euclidean or Manhattan distances.
In that case, Manhattan.
Yeah. I don't know, what is Manhattan distances?
Like Euclidean is point to
Yeah,
point,
yeah,
directly.
Euclidean is just, yeah.
Manhattan is like you have X and Y points are here, it's this way.
Oh, okay.
So
So
it's
it's like the taking the easy way out.
It's like x2 minus x1
Yeah.
plus y2 minus y1 instead of the square root.
Right. So it's like in this case, it's Manhattan distances too.
It's
yeah.
the legs of the triangle rather than the hypotenuse.
Wait,
Cool.
is that where you? Yeah, that's what I was doing.
Yeah.
And that's why I had problems with it. Like if you
Let's say
have to
it's
have it.
not the optimal.
No,
way of doing it
but, I
usually,
mean, it gets the specific case done. You know.
It like depends on the way you can move. Like if you can only move, 4 directions. It's like
you could move the diagonals on this one.
on this one, yeah, you can. See like northwest and stuff. But on the bot cleaning one, you couldn't. Like this one, Euclidean is better.
Yeah.
But the bot cleaning one, you can only move up, down, left, right. So.
But yeah, I just had it
Cool.
where it was